Recording in progress.
So we are dealing now with electromagnetic waves. Till now, what is the nature of our study? A static charge, charge inflow, charge behavior, a moving charge in magnetic field, and the relation between electric and magnetic field, interrelationship between electric and magnetic fields. So till now, we have studied something what we call Gauss law. This gives strictly about a static charge information, which you will write as a surface integration of E bar dot ds bar is 1 by epsilon naught times the charge enclosed, or integral 1 minute, or del bar dot E bar is 1 by epsilon naught times rho. So the same Gauss law in electrostatics. This is in electrostatics. The same Gauss law in magnetics results integral B bar dot ds bar is equal to 0, or del bar dot B bar is equal to 0. Del bar dot B bar is equal to 0. Magnetics. So the above statement, isolated charge exists, and this tells about monopole do not exist. And already we know Faraday's law. Faraday's law. Faraday's law states that E bar dot dl bar is minus of d phi b by dt, or curl E bar is minus dB bar by dt. Okay, so these are all vector forms. See, first two equations suggest individually the nature of static magnetic field, static electric field. The third one gives us an idea about a varying magnetic field is a source of electric field. Now the question is the reverse possible? Which means a varying magnetic field can be, a varying electric field, can that be a source of magnetic? For this purpose, let us try to understand a situation like this. Imagine that you have imagine that these are two capacitor plates. Say, for example, they were connected like this. At this point of time, you have a current current carrying like this at that instant. At this instant, let this be have a positive charge and this will be having a negative charge. We assume uniform sigma. And also we have a situation uniform electric field in between the plates of a parallel plate capacitor. I said the uniform spatially, everywhere field magnitude is the same. But with respect to time, the electric field might change. Now I will imagine a situation like this. Let us imagine some portion like this. I will define that this portion is having some area of cross section A1 and okay, this portion is having some area of cross section A1 and let this portion is having area of cross section A2. A2 is nothing but the plate. A1 is some region in between the plates. See, if I apply at A2, it is simply B bar dot DL bar is mu naught times I. It's the same current. Apply Ampere's law at A1. Honestly, there is no current carrying. But this proves that Ampere circuital law is giving two different results at two different places. But B must be continuous. Whether I choose this portion or whether I choose this portion, I can see the same B. But in between, there is no current, but still B exists. How is it possible? So this form of Ampere law is incomplete. This is purely incomplete. So we require some modification. For this purpose, they have introduced, in fact, Ampere-Maxwell's law. So according to him, Maxwell modified version of Ampere's law, he says that what is electric field in that region? Simply E can be given by Q by epsilon naught A and Q is changing. So therefore, here dE by dt is 1 by epsilon naught A di by dq by dt. dt. dq by dt. So therefore, if you push this epsilon naught, it is a d phi e by dt is a dq by dt. And this dq by dt is a current, and this is named as displacement current. This is named as, nothing is displaced here, remember. No charge is moving in between. But a moving charge is a cause of current. There is a current between the plates virtually. Otherwise, how do you have magnetic field? So Ampere's observation is a current carrying element is a source of magnetic field. There is no current literally between the plates. So at that time, understanding is maybe a current carrying element is a source. Now the complete understanding of that arrangement is a varying electric field is the source of magnetic field. So therefore, finally, this law is modified as this Ampere Maxwell's law is given as integral b bar dot dl bar for full circle for closed path is mu naught times normal current plus epsilon naught times d phi e by dt.
Recording in progress.
So this is the modified form of Maxwell's law. So don't ask me what is displacing. Nothing is displacing. When I said displacement electric field, did you know that anything literally displaced? No, not at all. Right. See, also notice that suppose if I am, this is the side view. This is the side view. And this is the top view. The side view, and that is the top view. Right. Right. In this, if I see that this is how the electric field is directed into the area. See, when I said that this is the direction of the electric field, obviously what will happen when someone who is seeing from that end, it's an inward field. Now you see R radius. Now in this, what is the magnetic field? What is the direction of the magnetic field? So dE by dt, no, 1 minute. What is the direction of magnetic field? Obviously, del bar cross B bar is mu naught epsilon naught dB bar by dt. Curl means always right hand grip. Okay. So if I am if your dB bar by dt, you want 1 minute, one thing is wrong. dE bar by dt. The electric field, so don't get confused between the rules of induction to the rules of this one. There is a minus relation. Del bar cross E bar is minus dB bar by dt. Here del bar cross B bar is a plus mu naught epsilon naught dE bar by dt. So therefore use right hand. Thumb represents electric field direction and curl the fingers of the right hand. That gives the direction of the magnetic field. So therefore, B into 2 pi R is mu naught epsilon naught dE by dt, mu naught epsilon naught d phi అప్పుడు ఏం రాయాలి మీరు ఇక్కడ d5b by dt వెక్టార్ రాదు కదా నాన్న అది అరే యార్ వాట్ ఐ హావ్ రిటర్న్ ఇస్ కరెక్ట్ డోంట్ కరెక్ట్ మీ హియర్ you're using this relation over here mu naught epsilon naught pi r square dE by dt. So B is mu naught epsilon naught dE by dt by 2 times R. If you know dE by dt, what is dE by dt? dE by dt is dq by dt times epsilon naught that factor. Don't get confused. Again, please try to understand. E is the total charge that instant, and dE by dt is dq by dt times epsilon naught. This is for full plate. Don't forget that. The E what I have referred to is for the full plate. When I am taking Q as a full charge. So therefore now B can be written as epsilon naught dE by dt can be written as mu naught pi r square by 2 times R. Just please correct me if I am wrong anywhere. B into 2 pi r is mu naught epsilon naught dE by dt. Here I have done mistake. No one noticed that. 1 minute. I'll write it very properly. Left side part is absolutely correct. Right side part I'll correct it properly. So B into 2 pi r is mu naught epsilon naught pi r square dE by dt. Mu naught epsilon naught pi r square. Forget about epsilon naught. Epsilon naught dE by dt can be written as dq by dt by pi r square. So therefore, B can be written as mu naught dq by dt, okay, by 2 times pi r square times small r. So finally I proved B proportional to small r, which means at some distance R, what is the magnitude of B? This is the magnitude of B. Now I'm asking you, do you have any doubts till this point? Do you have any doubts till this point? Asking you again, do you have any doubts till this point? So that is the introduction to displacement current. So finally, all these equations will form Maxwell's equations. So what are Maxwell's equations? One thing, E bar dot ds bar is 1 by epsilon naught times the Q enclosed, or del bar dot E bar is rho by epsilon. Similarly, this is called Maxwell equation 1. D bar dot ds bar is 0, or del bar dot B bar is 0, equation 2. Okay. And surface line integral of E bar dot dl bar is minus d phi b by dt, or del bar cross E bar, this is called curl, is equal to minus dB bar by dt. The meaning of the third equation is a varying magnetic field is a source of electric field. So the fourth equation, Ampere-Maxwell's law, is mu naught I plus I displacement current, or ఇప్పుడు పొద్దునే వచ్చిన 7 కాదు పొద్దునే 7ంటికే వచ్చి 6 కదా మార్నింగే వచ్చి.
అవును సార్, ఇది పాజిటివ్ అని ఉంది, అదేంటి
స్కోర్లో పాజిటివ్ స్కోర్ అంటే నెగిటివ్స్ తీసేస్తే వచ్చేది పాజిటివ్ స్కోర్.
కానీ వాడు కరెక్షన్ చేయనట.
కాదు, ఇప్పుడు వీడు 5 క్వశ్చన్లు చేశాడు, 30 మార్కులు వచ్చినాయి. 6వ క్వశ్చన్ -2 చేశాడు. సో వాడు రాసేది 30, 28 రెండు చూపిస్తాడు. 28 కన్సిడర్ చేస్తాం. ఆర్ del bar cross B bar is mu naught times I, 1 minute, mu naught times mu naught epsilon naught dE bar by dt, equation 4. Or ఇది ఎప్పుడు when there are no currents. If there are currents, mu naught J plus epsilon naught dE bar by dt. These are Maxwell's equations. So with these equations, Maxwell proved mathematically that there exists a situation a varying electric field is a source of magnetic field. In converse, a varying magnetic field is again a source of electric field. So this results that there exists a wave called electromagnetic wave, which is such that the electric field oscillates, magnetic field oscillates mutually perpendicular to each other, and they are perpendicular to the direction of propagation of the wave. Is theoretically proved. 20 years later, the proposal of Maxwell's theory, 20 years after the proposal of Maxwell's theory, Hertz produced and discovered electromagnetic waves. So the person who is responsible for EM theory is none other than Maxwell. Right. So a simple experimental setup. Actually, I told very clearly, Hertz produced and detected EM waves. And a simple
Recording in progress.
this is the experimental setup used by Hertz. See, according to Hertz, an oscillating charge is a source for EM waves, and frequency of oscillation of a charge is equal to frequency of EM wave. That's the fundamental. Now let us work on this part. Let us work on this part. Right. This is the Hertz experimental setup. So long the charge oscillates, EM waves are produced continuously. That's the logic observed by Hertz. Now you have metallic plates P1 and P2. Metallic plates, and which are connected to spheres, small spheres S1 and S2. And they act as capacitors. And they act as capacitors. You are applying actually an AC source. You're giving an alternating voltage to these plates, which means the charge on these spherical capacitors alternatively becomes plus minus plus minus plus minus. Likewise, when high voltage మరి sufficiently high ఉండాలి కదా at least to detect. Higher the voltage, higher will be the amplitude of the EM waves. So when high voltage is applied across the plates, comma, S1 and S2 gets charged, and they are placed very close. The gap is very small. What will happen? Discharge takes place. Right? And there you are accelerating an electron. Right or not? So sometimes acceleration happens from one plate to other. Say, for example, say S1 to S2. The other occasion, it happens from S2 to S1, alternating. Charge is oscillating. This oscillation charge is the source of EM waves. So I repeat, P1 and P2 are metallic plates connected to spheres S1 and S2, and they act as capacitors. When high voltage is applied across the plate, S1 and S2 gets charged and gets discharged. Okay, by sparking, actually you can also see this by sparking in a narrow gap. I have everything shown in the figure. So in fact, this is the gap I'm speaking about. And they generate this will generate EM waves of frequency F is equal to 1 by 2 pi root LC. రామ్ గారికి నేను అడిగా అసలు ఎల్తో పన్నెండు సార్ సితో పన్నెండు సార్ ఇగో అది పని అప్పుడు చెప్తే ఏమర్థం అవుతుంది అంటే వాట్ ఈజ్ ఎలక్ట్రోమాగ్నెటిక్ వేవ్ అని అడుగుతావు అప్పుడు అంతే కదా ఇది ఈజ్ ఎలక్ట్రోమాగ్నెటిక్ నౌ ఐ హావ్ టాట్ ఎల్సి ఆసిలేషన్స్ యు సీ దిస్ ఈజ్ ఎల్సి ఆసిలేషన్స్ బేసికల్లీ ఎనీ డౌట్స్ boys and girls? What to have a doubt in this is an information that I am giving, what was observed by heads. I am not putting any of my mind here. I am just transferring data, that's all. Similarly, when they receive, automatically the same phenomena is noticed in reverse. These electromagnetic waves charge S1 dash S2 dash differently, and you will see the same oscillations in that receiver. And that oscillations, if you tune that circuit to the exact frequency what was produced by Hedge, then you will receive current. You can sense current. So production and detection. So what are the sources of electromagnetic waves? Basic sources of electromagnetic waves. The first point, accelerating charge. So they produce E field, B field, electric field, magnetic field, and that varies with the time. That varies with time and space. And this results in the formation of electron. This is the basic production. 2. LC oscillation. 3. Bohr's electron transition. From one orbit to another orbit. ఇంకా X-rays. Where accelerated charge when collides with a target material, X-rays are produced.
X-rays EMS కావాలి సార్.
EM waves ప్రొడ్యూస్ చేస్తున్నాం EM waves అక్కడ X-rays రూపంలో. What are you using in X-ray? That I will discuss later again. Don't ask me now. How are X-rays produced? A charge fast moving electrons, when they strike the target material like molybdenum, tungsten, etc., that results in the production of X-rays. That is one way of producing electromagnetic waves. Next, how the way electron transition, nuclear reactions, gamma rays also produce electromagnetic waves. So a charge at rest is not a source of electromagnetic wave. A steady magnetic field will not produce electromagnetic wave. A charge moving in a circular orbit, uniform angular velocity will not produce electromagnetic waves. A charge moving along a straight line with constant velocity also will not produce electromagnetic waves.
సార్ యాక్సలరేటెడ్ చార్జ్ ప్రొడ్యూస్ చేస్తుంది.
అవును.
సర్క్యులర్ మోషన్.
ఆ యాక్సలరేషన్ ఈ యాక్సలరేషన్ ఒకలాంటిది కాదు. న్యూక్లియస్ చుట్టూ తిరిగే ఎలక్ట్రాన్, it won't produce electromagnetic wave. Right or not? Once it undergoes a change in orbits, it will produce electromagnetic waves. What we are discussing right now is plain electromagnetic waves. We right now whatever discussing are plain electromagnetic waves. Like for example, what I am pasting over here is a plain electromagnetic wave. So what is the significance of this? You can see the electric field is in one plane. Magnetic field is also oscillating in another plane, mutually perpendicular to each other. And this is perpendicular to the direction of propagation. So here if E bar electric field vector, B bar is magnetic field vector, I will represent E bar as E naught sin omega t minus kx j cap. P bar is B naught sin omega t minus kx k cap. And therefore, the direction of here, what is omega? You already know wave properties 2 pi f 2 pi by t. You already know k. K is called propagation constant 2 pi by lambda. You already know all these things. And c, the speed of light, omega by k or f lambda, whatever you want, you write. You already know what is the c. It is mu naught epsilon naught. I will derive this equation later, which is of no use for us, but I'll just derive some other class. So in a medium, this is air. In a medium, you will write this as mu naught, 1 minute, mu naught mu r epsilon naught epsilon r. which means C naught by root mu r epsilon r. Also, you know the relation already. You have noticed this in magnetics. E by B is C. E by B is C. Here, in this case, this is speed of light. Right. So that's all. So these are basic information. Basic, very basic information. Not more than this. So I have just introduced what is electromagnetic wave and etc. like kind of thing. Okay? Just basic introduction to electromagnetic waves. Just basic introduction. And we know a lot of information by this time already related to in a inductor, energy is stored in the form of magnetic field. In a capacitor, energy is stored in the form of electric field. And we know energy densities also. So one thing that you need to note is because you know wave carries both energy and momentum. We have studied this a long time back. In the month of November, September, October now, November only, I think, after SH. Waves we have studied. A wave carries both energy and momentum. See, one thing that you need to know is, this is a very, very, very important term. Energy possessed by EM waves is equally distributed between E and B. I think you can understand from this. Electric field and magnetic field. You know, energy density of electric field formula is half epsilon naught E square. Whereas energy density of magnetic field is B square by Q mu naught. I said equally distributed. From this only you got C actually. E square by B square is 1 by epsilon naught mu naught. E by B is 1 by root mu naught epsilon naught. E by B is C. Now what is the total energy density? Half epsilon naught E square plus half B square by mu naught. So therefore, one thing that you need to understand is, you can write this simply as epsilon naught E square or B square by mu naught, because they are same. Because they are same. Right. Right. And one more important point. Whatever that I have written, this is అన్న 10 minutes చేస్తా, క్లాస్ అయిపోద్ది. రైట్. Whatever that I have written here is the instantaneous value. Whatever I have written here is an instantaneous value. But these are all sinusoidal functions. So what you require is the average values of these things. As I mentioned, E is E naught sin omega t minus kx. B is B naught sin omega t minus kx. So you require average values. So therefore, the average value, U average value is nothing but 1 minute, 1/4 epsilon naught E naught square plus 1/4 B naught square by mu naught. Any doubt? You can ask me. Just we have done very recently. The average value of cos square for cycle, the sine square for a cycle is 1/2. Already there is 1/2 this thing. So the average value of E square is E naught square by 2. Similarly, B square, B naught square by 2. So by which you can write it like this. So this can further be written as half epsilon naught E naught square. This can be written as B naught square by 2 mu naught. This can be written, this can also be written as epsilon naught E RMS square, and this can also be written as B RMS square by mu naught. RMS value, right? Okay. Any problem that comes from electromagnetic waves, one part of electromagnetic waves will directly come from this. This para alone will solve 30 to 40% of all previous electromagnetic waves based questions. Again, 30% is done. Okay, I'll just stop over here.